So today we're going to take a look at a couple more segment rules within our circles. So the first one is going to be tangents drawn to the same external point. And the rule here is that all tangents drawn from the same external point will have the same length and they'll essentially be congruent. So the proof for why that is as follows. So if I take a look at two tangents, so tangent CB is drawn to point B, and tangent DB is also drawn to point B. So our rule is that these two tangents are equal. They are the same length. And the reason why, we could kind of do a quick little proof here, and I think that this will be one that makes a lot of sense. So if we look at our two triangles, triangle ABC, and we look at triangle ABD, let's figure out why these two triangles are congruent. So the first thing I could look at is that they have a reflexive. That's easy enough. They both share AB, so AB is reflexive. That's one side. Then AC and AD are congruent because they're both radii. They're both a radius of the circle. All radii are congruent. AC is a radius, AD is a radius. And the last thing we learned about it briefly last unit was that a radius and a tangent, they form a right angle. So there's a right angle there. A radius and a tangent meet to form a right angle. So there we go. We have three parts. It's in the side-side angle formation. So we could say triangle ACB is going to be congruent to triangle ADB by HL, hypotenuse leg. They are congruent by hypotenuse leg. So now why does this prove that tangents BC and tangents BD have to be congruent? Well, now they're going to be congruent because the triangles are congruent. If the triangles are congruent, all of their parts are congruent, and that's simply due to CPCTC. Corresponding parts of congruent triangles are congruent. So that's our proof as to why tangents drawn to the same external point are congruent. So look at a couple examples here. We have a circle is inscribed in a triangle, and the circle and the triangular tangent, they meet at points D, E, and F. Those are the only points that the circle intersects the triangle. Then they also tell us that AD is 4, BF is 6, and CE is 7. We want to find the perimeter. Okay, now using our rule that tangents drawn to the same external point are congruent, well, we can say AD and AE have to be congruent. CF and CE have to be congruent. BF and BD have to be congruent. So if AD is 4, AE is 4, CE is 7, CF is 7, and if BF is 6, BD is also 6. So if we want to find the perimeter, perimeter means add up all of our sides. So this is 10, this is 11, and this is 13. If we add that up, 10, 20, is that 34? 34 would be our perimeter, 34 units. Okay, so let's take a look at another one. In this case, they're telling us that AB, BC, and AC are all tangents. So this whole thing is 16. This whole thing is 20. And they tell us AD is 6. We want to find the length of B to C. So we want to find the length of this entire thing. Okay, well, if this whole thing is 20 and this little piece is 6, then that's easy enough. This is 14. Okay, so then we could say, all right, well, if DC is 14, then FC is also 14. If this is 6 here, these both have to be congruent. So this is also 6. Well, then that would make this here BE 10. And then if BE is 10, BF is also 10. So then we want to find the length of this entire thing. So that's going to be 24. So it's kind of like a little puzzle. You just kind of fill in things as you go. We'll look at one last one. They tell us the whole thing. BC is 20. BD is 8. Find the length of CE right over here, x. Okay, if DB is 8, then BE has to be 8. If this entire thing is 20 and this is 8, well then this has to be 12. And that one was a little bit easier. We didn't have to find as much. CE equals 12. All right, so that's two tangents drawn to the same external point. Pretty straightforward. The next thing we're going to look at is secant segment length theorem. And that is, I'll read this out here. If two secants are drawn from a common exterior point, so in this example, we have two secants, they go straight through the circle, they're drawn from the same external point P, then the product of the length of one secant with the length of its external segment is equal to the product of the length of the other secant with the length of its external segment. So that's kind of a lot going on there. What it basically means is PC is the whole secant, PA is the external portion, PD is the whole secant, PB is the external segment. So when I kind of think about it, it's the whole secant times that external portion is equal to the whole secant times the external portion. So in this case, it's going to be PC is the whole secant, and the external portion is just PA. That's going to be equal to the whole secant, PD, times the external portion, which is just PB. And that will make them equal. So let's take a look with numbers here. I think sometimes it gets a little bit easier when we throw numbers in there. We have two secants. They're drawn to the same external point A. AB is 6. BD is 2. AC is 4. Find the length of CEX. Okay, let's figure out what our whole secants are. So 4 and x, that's x plus 4 is the whole. And 6 and 2 is 8. Okay, so remember, it's the whole secant times the external portion of it equals the whole secant times the external or the outside portion. Okay, so our whole secant here is 8. And the external portion is 6. AB is the external portion. On the other side, the whole secant is x plus 4. This whole thing is x plus 4. And then the external portion is 4. Now we have an equation that we could go ahead and solve out. So 8 times 6 is 48 equals 4x plus 16. Let's subtract 16. So that's going to be 32 equals 4x. And x equals 8. And that's what we wanted to find. We wanted to find CE. CE is x. So CE equals 8. So looking at this next one, again, two secants. PA is 5. AB is 15. PD, the whole thing, is 25. Find the measure of CD. I'll call this x. Okay. Let's fill in our last piece. We need to know, well, we could do this. This whole thing is 20. And then we want to know what PC is. If the whole thing is 25 and CD is x, well, then that's going to be 25 minus x. Okay. So they're two secants, so it's the whole secant times the external is equal to the whole secant times the external portion. Whole secant is 20. External portion is 5. Whole secant is 25. And the external portion is 25 minus x. Okay, so let's go ahead and multiply this out. That's 100 equals 25 times 25, I think is 625. Okay, minus 25x. We'll solve this out. So subtract 100, and that's going to be negative 525 equals negative 25x. And then divide both sides by 25. We get x equals 21. Since we put x as to what they wanted us to find, we're done. CD equals 21. That's our answer. That's what x was. I'll take a look at this last one before moving on to the last theorem. In this one, two secants again meet at P. PA is 5. PB is 15. PD is 25. Find the measure of CD. Is this the same exact question? Yeah, it's the same exact question. Okay, cross it out. Moving on. Okay, last one is when we have a tangent and a secant. So we just did tangent, tangent, then we did secant, secant. Now we're going to look at tangent, secant. So the rule for that is if you have secant and tangent drawn to the same external point, then the product of the length of the secant with the length of its external portion is equal to the square of the length of the tangent. So for this one, it's going to be the whole secant times the external portion is equal to the tangent squared. Okay, so it's the whole secant, which is PC, times the external portion, which is PA, is equal to the tangent squared. Okay, whole times external equals tangent squared. So here we go. We have a tangent. PA is a tangent, and PC is a secant. PB is 4. BC is 5. What is the length of PA? I'll call that x. So it's going to be the whole secant times the external portion is equal to the tangent times itself twice, or tangent squared. So the whole secant here, 4 and 5, is 9. The whole secant is 9, and that outside portion, PB, is 4. That's going to equal our tangent, which we don't know. It's going to be x times itself, so x squared. This should be 36 equals x squared. Square root both sides. Technically, we would get plus n minus 6, but really we're just looking for the positive portion of it. So x is 6, so PA is 6. Okay, here we have, this time we have the tangent. The tangent is 8. BC is 12. What is the value of PC? I'm going to call that x. Okay, so let's get that external portion. If the whole thing is x and BC is 12, we're going to call this x minus 12. So the whole secant is x. The external portion is x minus 12. And that's going to equal the tangent squared. Multiply it out. X squared minus 12x equals 64. Set it equal to 0 because it's a quadratic. Now we're going to factor and solve. So we need to think what multiplies to 64 but adds to 12. So we need to think about what multiplies to 64 but adds to a negative 12. Actually, what multiplies to a negative 64 and adds to a negative 12. That's going to be negative 16 and a positive 4. Okay. So that factors to be x minus 16, x plus 4. That equals 0. Set both of these equal to 0, and we're looking at x equals 16 and x equals negative 4. And we don't want to reject the negative just because it's negative, but we do reject it here because when we substitute it back in, we're starting to get negative lengths. So we're going to keep x equals 16. They wanted to know the value of PC. That's where we put our x, so we could leave it as is. Okay, and the last one here, we have secant. ADC is drawn and has a length of 12. AD to DC is in a ratio of 1 to 3. Determine the length of AB. Okay, so AB is x. And then AD to DC is in a ratio of 1 to 3, but the entire thing is 12. So if it's in a ratio of 1 to 3, I'm going to use y's here maybe. So I could say 1y plus 3y has to equal 12. The whole thing is 12. It's in a ratio of 1 to 3. So 4y equals 12. Y equals 3. So that means that this is 3 and this is 9. That makes it a 1 to 3 ratio. 3/9 is 1/3. So it's in a 1 to 3 ratio. Okay, so it's the whole secant, that's 12, times the external portion, which is 3, is equal to the tangent squared. So x squared. We have another 36 equals x squared. So x equals 6. Okay? All right, so we'll stop there. And at that point, we've done all of our segments. We're going to take a look at proofs next, the last proofs of the year, thankfully, and that's it. So have a good day. Bye-bye.